Hi everybody, this is going to be our first Chapter 7 video, and we're going to talk about factoring. We're going to start off just talking about what factors are, and we're going to look at a specific example to discuss factors. So, back in elementary school, you talked about finding factors of a particular number. Now, we have pairs of numbers that multiply to give us 24. So if we write out that list, okay, for 24, we could do 1 and 24, we could do 2 and 12, we could do 3 and 8, we could do 4 and 6. Okay, and keep in mind that the order that I multiply in doesn't matter. Like 4 times 6 is the same as 6 times 4, so we don't need to include that twice. But what this does is we can compile these numbers into a list, and we say that all of these numbers are factors of 24. Okay, so we're going to build on this. We're going to build onto this by looking at two numbers and finding the greatest common factor between them. We're going to incorporate some variables in there. So we're building on this idea of what factors are. So let's kind of review real quick of what we've been doing recently. We've been multiplying polynomials together, so we've been doing things like this where we distribute to get 3a squared plus 7a, or we can have three things here, be negative 2m cubed minus 12m squared plus 2m, or we can even have multiple variables. So we get 5x squared y minus 10xy squared. So we've been multiplying and getting these polynomials, but what we're doing now is we're going to start kind of doing this in reverse. We're going to take a polynomial like this and we're going to factor to get it back into this form. Okay? So each of these, we're going to take factor and get it back into that form there with the parentheses. So all of these that you see here are what we'll call factored form. Because really when I have something like a times 3a plus 7, each one of these is a factor. Okay, a is a factor, and 3a plus 7 is the other factor. Together, when these two factors multiply, they give us 3a squared plus 7a. So we're trying to factor out polynomials to figure out what did we multiply together to get that polynomial. Okay, and it can be kind of tricky. So I want you to jot down this quick definition for what factoring is. Okay, factoring is a process that separates polynomials into its factors. Okay, and remember, factors are things that multiply together to give us a particular number, or in this case, polynomial. Okay, when we have polynomials that can't be factored, because not all of them are factorable, then those polynomials are prime. But a lot of the times, if we have one that can't be factored, we'll just say, hey, this polynomial can't be factored, and that's it. Now, the other thing we need to talk about is, what is a GCF? Okay, well, a GCF is something really important when we come into factoring here. A GCF stands for greatest common factor, and I'm sure that you've seen this in elementary school or maybe middle school. You've definitely talked about these in your earlier math classes. So let me give you an example. If I wanted to find the GCF between 4 and, let's say, 6. What we need to do is find which factor these have in common. Okay, and if there's multiple factors they have in common, the GCF is the greatest of those common factors. So 4 has factors of 1, 2, and 4. Okay, 1 times 4, 2 times 2, so these are all the factors of 4. 6 is 1, 2, 3, and 6. 1 times 6, 2 times 3. So looking at these lists, the GCF is 2 because that is the biggest factor that they have in common. Okay, now, this can be inefficient. If we have numbers with a lot of factors, this process of listing them all out to find the GCF can be pretty burdensome. So we want to get to the point where we can do this mentally. So another way that you can think about this is, to find the GCF, think about what is the biggest number that 4 and 6 are both divisible by. Okay, the biggest number that those are both divisible by is 2, okay, which gives us the same answer that we found by listing them out. So you can always find a GCF by thinking, what is the biggest number that each of those are divisible by? Okay, so keep that in mind. Now, we're not going to just be finding greatest common factors. We're going to be actually factoring these out of polynomial expressions. So when we look at number 1, we have two terms, 3x and 12. We want to factor out the greatest common factor. So we need to think about what they have in common to begin with. Okay, they both have numbers. They don't both have x's. Okay, so the only thing that we can find in common here is between 3 and 12. Okay, so let's think. What's the biggest number that 3 and 12 are both divisible by? They're both divisible by 3. So here's our general format. We always put our GCF in front of a set of parentheses, and what goes in the parentheses is what's left over after I factor out 3. Now, keep in mind, we started with 2 terms originally, so we should have 2 things inside of our parentheses here. Okay, this is what's left over after we factor out 3. Now, to figure out what's left over, we go back and divide each of our original terms by that GCF. Okay, so 3x divided by 3 is x, plus 12 divided by 3 is 4. So this is our answer. This is the factored form. Now, here's the nice thing. When we're factoring, we can always check our work to make sure that we are 100% correct. Because if I take these factors of 3 and x plus 4, okay, each of those are a factor, if we multiply these back together, it should take us to what we originally started with. So we can distribute to check our work. 3 times x is the 3x that we see here. 3 times 4 gives us the plus 12 that we see here. So that's how we can check our work, and you can just do this mentally. Okay, so for a second example here, we're trying to figure out what they have in common. Okay? Okay, only one of them has a variable, so we're looking at just the numbers here, and we're thinking, what is the biggest number that 7 and 7 are both divisible by? Well, they're both divisible by 7. We put our parentheses, and we're going to have 2 things inside that are left over. So we go back, we divide 7y, and the minus 7 here by 7. 7y divided by 7 is y, minus 7 divided by 7 is 1. So 7 times y minus 1 is our answer. Okay, let's look at an example where we have some variables in common. Okay, let's skip to number 6 here. When I look at number 6, I notice that both of my terms have a y. Okay, so we still need to factor out a GCF between the numbers. Okay, we can divide 4 and 24 by 4. But now that each of our terms has a y in common, we can also factor out a power of y. Now, the rule for variables is you can only factor out the lowest power of that variable. So we have a y squared and a y to the first power. So the smallest power of y is just y to the first power, or y. So not only are we going to factor out 4, we're also going to factor out a y. So that makes up my GCF. Okay, we're going to have 2 things left over here. So we need to go back, divide each of my 2 things by 4y. And our exponent rules come into play now. 4y squared divided by 4y is y minus, okay, well, 24 divided by 4 is 6. When the y's divide, they turn into a 1. They just cancel each other out. So this would be our answer. And this is what most of our problems are going to usually look like. Okay, we're going to have a common variable in addition to this number that can be factored out. Okay, so let's look at some examples with multiple variables. Okay, Number 7 here. Let's start with the numbers. We always like to start with the coefficients, and then we can take a look at the variables. So 21 and 3. The biggest number that those are both divisible by is 3. So now we need to look at the variables. Okay, my first term has a C and a D, but my second term only has a D. So what they have in common is D. So we'll factor D out with the 3. Okay, so now we can go back, divide each of these by 3D. So 21 divided by 3 is 7. The D's divide and cancel out, so we still have a C there, minus 3 divided by 3 is 1. D divided by D cancels out, so we just have 7C minus 1 here. And what about if there's 2 variables that they have in common? Well, we still do the numbers first, 15 and 30. Okay, those are both divisible by 15. I have an a squared and an a, so remember we can factor out the smaller power of the 2, and they both have b. So the GCF altogether is 15ab. We go back and divide. So 15 divided by 15 is 1. A squared divided by a is a, and the b's cancel out. 30 divided by 15 is 2. The a and the b cancel out when we divide. So 15ab times a minus 2 would be our final answer. Okay, I want to look at one more example where we have 3 terms. Now, when we have 3 terms and we're trying to find the GCF and factor the GCF out, we have to find what is in common between all 3 of these terms. Not just 2 of the 3, but all 3 of them. So we need to figure out what the biggest number that each of these 3 numbers is divisible by. Okay? All 6, 14, and 10 are all divisible by 2, and that's the biggest number that they're divisible by. Now, each of these terms also has a power of y. Remember, we can only factor out the smallest power, so y squared. Now, we go back and we divide each of these 3 terms by 2y squared. So we get 3y squared plus 7y minus 5. All right, so that is it for this video over factoring out GCFs. Please rewatch, rewind, pause, and ask questions if you haven't. Have a great day.